Hello viewers, in today's session we are going to discuss some important problems related to finding out the higher order derivatives of functions. Right, so here we'll solve some important problems in which the higher order derivatives are involved. Right, so let us take the problems one by one. Now consider this third problem in which we are given that y 10x is equal to 1 and we have to prove that d2y over dx2 plus 2y dy over dx is equal to 0. Right. So from this relation will start, and we are given that y times 10x is equal to 1. So we can rewrite this expression as y is equal to 1 over 10x, that is equal to cot x. Right, so now differentiating both sides with respect to x, we have dy over dx is equal to d by dx of cot x, and from the standard result we know that the derivative of cot x is minus cosec square x. Right, and from trigonometry we know an important identity connecting the two functions cot theta and cosec theta, as 1 plus cot square theta is equal to cosec square theta. So here we can now write cosec square x as 1 plus cot square x, and for cot x we can write y, so we have minus 1 plus y square because cot x is equal to y. So we have this result, that is dy over dx is equal to minus 1 minus y square. So taking these two terms to the left hand side, we have dy over dx plus y square plus 1 is equal to 0. Right, so now differentiating both sides with respect to x, we can now write d by dx of dy over dx plus y square plus 1 is equal to 0 because the derivative of 0 is 0. So now differentiating term by term, the first one is d by dx of dy over dx, and then we have d by dx of y square, and here the derivative of 1 with respect to x is 0 because 1 is a constant and the derivative of a constant is 0. So now d by dx of dy over dx is d2y over dx2, and the derivative of y square with respect to x is given by 2y dy over dx, and this is equal to 0. Right, so here the derivative of y square with respect to x is calculated as follows, that is d by dy of y square. So first we differentiate y square with respect to y, and then by chain rule we have dy over dx. So here we can make use of the chain rule, that is d by dy of y raised to n is ny raised to n minus 1. So here we have 2y, y square, the derivative of y square is 2y, and then by chain rule we have dy over dx. So here we have 2y dy over dx. So d2y over dx2 plus 2y dy over dx is equal to 0. So this is the result which is to be proved. So now let us consider this fourth problem. This is also a very important problem, and we have to find the third derivative, that is d3y over dx3 at x is equal to 1 if y is equal to log of x cube over e raised to 4. Right, so here we are considering the natural log, and we are using the notation log instead of ln. Right, so we can also write this relation as ln x cube over e raised to 4, right? So first we have to find the third derivative of y with respect to x, and then we'll take x is equal to 1. So now we have y is equal to natural log of x cube over e raised to 4. So here we can make use of this property of log, that is log of a over b is log of a minus log of b. So we can now write y is equal to log of x cube minus a log of e raised to 4. So this is y, and again using the properties of log, log of a raised to say m is m times log of a. So here we have 3 times log of x, and here we have 4 times log of e. Now the natural log of e is 1, so we have y is equal to 3 times log of x minus 4 times 1. So y is 3 log x minus 4, right? So the given relation y is equal to log of x cube over e raised to 4 can also be written in this form. So now differentiating both sides, with respect to x, we have dy over dx is equal to 3 times the derivative of log x, and the derivative of 4 being a constant is 0. So we have 3 times 1 over x, that is 3 over x. The derivative of log x with respect to x is 1 over x. So the first derivative is equal to 3 over x. Now the second derivative is given by differentiating both sides with respect to x. So we have 3 times the derivative of 1 over x. So this is 3, the derivative of x raised to minus 1, and using the power rule for differentiation, that is nx n minus 1, we have 3 times minus 1 over x square, right? So the second derivative d2y over dx2 is given by minus 3 over x square. Now to get the third derivative, we can differentiate both sides with respect to x. So we have d by dx of d2y over dx2, and here we have minus 3 times the derivative of 1 over x square. So this is the notation for the third derivative, d3y over dx3, and here we have d by dx of x raised to minus 2. So again using this power rule here, we have minus 3 and we have minus 2 over x raised to 3, right? So the derivative of x raised to minus 2 is minus 2 over x cube. That is multiplying both these quantities, we have minus minus plus, so we have 6 over x cube. So the third derivative is given by y triple prime. The notation for the third derivative may also be used, this notation. So we have 6 over x cube. Now we have to find the value of third derivative at x is equal to 1. So taking x is equal to 1 over here, the value of the third derivative at x is equal to 1 is given by 6 over 1 cube. So this is 6 over 1, because 1 cube is 1, that is equal to 6, right? So the third derivative at x is equal to 1 when y is defined like this is equal to 6.